Hello, I'm Damski, and we are here at ETHPrague with Thor Kamphefner from Entropy. Welcome, Thor. How are you doing?
Hey, Damski. I'm doing well. How are you?
I'm fine, actually. Enjoying the vibes in ETHPrague. Everything is going pretty well. Scheduled some interviews for today, so let's kick it off. So, for starters, can you tell us something about yourself and your position at Entropy?
Yeah, for sure. So I got into cryptocurrency world in 2018. I was working with my mentor in San Jose on the Ethereum beacon chain security proof paper called Gasper, and that's sort of how I got my introduction. Lately, I've been running a zero-knowledge study group called Proofs, Arguments, and Zero Knowledge, and I also work as a cryptographic engineer at Entropy on multi-party computation.
All right, that's a pretty solid starters, I would say. I would say a pretty solid campaign going in the way. So my question is, what do you think are the future trends in the let's say security models or in this space in general, in the blockchain space?
I mean, to take a sort of like broad question and modularize it, I think like the kind of questions are, like broadly speaking, how quick are we going to be able to get zero knowledge circuit technology into production? That's one of the big ones. Another big one, of course, is like how soon quantum computers arrive, but I'm kind of bearish on quantum computers arriving very quickly. There was recently a sort of scandal that one of the major quantum computing companies was shown to be mostly lying about all of their claims. So I think like a lot of the questions that I have about security have to do with like either on the research and development end, like how long do we expect for like realistic ZK circuits to be in production? And if we actually can get like hardware for real ZK applications on like optimized circuits, we can do some really impressive and efficient stuff. On a more security end of things, it's really just a question of like, what is it going to take to reduce the number of like, or reduce the available attack surface on crypto? Because like, I mean, you see pretty much every week there's like a couple $1 million paid for bug bounties, and that's if it's a good week. If it's a bad week, it's a couple $100 million because some major protocol got hacked. So I think like one of the major questions in security is actually kind of a social question, like what is it going to take to secure cryptocurrency applications in a more sort of systemic and robust way? And I think that there's a lot of pressure on applications to come out and push as quickly as possible, but kind of hope for the best that their audits are holding up. So it's a kind of complicated question, but I think that's sort of where my head is.
I definitely agree on these parts you said, because for example, making a custodial versus non-custodial wallet and securing it through like cryptography can be sometimes a little bit tricky, especially when you are trying to like tackle multiple blockchains. So my question is, what basically has cryptography in general, what effects has it done to Web2 world? And like, let's say we are in the Web3, like how do you think we are transitioning through cryptography to Web2 world?
Well, I think like if we're going to be sort of self-critical here, like to steelman the Web2 position, that there was a letter signed by Bruce Schneier and 15 other computer scientists and engineers last week that sort of announced that all of Web3 was garbage and that legislation should be passed to just kind of ban all of it. And I think like if I really wanted to steelman that position, it's that we've like really managed to open up a whole bunch of opportunities for like people who are ambitious to do a lot of work for good, but also do a lot of work that's sort of not scrutable to like traditional entities. So I think like I would broadly divide up my counterclaims to that into like two categories. One is like the sort of autonomy of the individual that wants to create something without necessarily wanting to be subject to the tower of like established legislation and like norms that we've built up in like the traditional legal system and banking system. And the other has specifically more to do with like payments and finance. I think the latter is sort of like markedly like unusual in IT in the sense that like we've done a really incredible job in the last 50 years of like making networks that make it possible to communicate more efficiently by like in unfathomable scales to what would have been true like maybe even just 20 years ago. Payments technology, not at all. Like actually payment companies take more as a percentage now than they did 20 years ago often. So I mean that's just like completely nonsense. Finance also is like a heavily scrutinized field. And I think that's maybe sometimes justified, especially since the games that are playable at like the largest scale of hedge funds are just unfathomable to common people. And so if they think that they're going to get into a game like playing like a hedge fund, maybe the protections are there for their own benefit. But I think a lot of them are just kind of nonsense that have just been there for long enough that they're just sort of accepted as normal. So I think there's a lot to be said for the democratization of access to financial games and services that DeFi is creating. And I think there's a lot to be said for the making available of the tools to do sort of self-autonomous governance. And I'm really quite interested to sort of see the direction that we're playing games and experimenting with new governance structures that I think are really exciting, because I think like the whole of human like value, like the history of human value creation exists as a sort of testament to like the power of collaboration. And a lot of these sort of financial games and these governance games are really all about how can we do that better. And I think that's really exciting.
Well, if we look at Web3 in general, at this space that we are here at ETHPrague, and there are a couple more conferences, there are a couple like more coming up in the summer and throughout the year. So, what is the biggest challenge that we are facing in the blockchain space or in the Web3 world at this particular moment?
Well, I think that's kind of like hard to like take at face value. Is like, what is the biggest challenge? I think kind of depends on what you think that cryptocurrencies are actually trying to solve. If you think cryptocurrencies are trying to solve privacy, then the answer is something to do with zero knowledge circuits. If you think the answer is that we're trying to preserve autonomy from like tyrannical governments, as I think a lot of like the anarchic roots of cryptocurrencies are concerned, I think like a lot of the currencies that have gone mainstream are sort of irretrievably distant now from like the anarchic like in concepts that like the Satoshi and the CryptoPunks kind of guys would have liked to have been true. I really feel like the question sort of drags you into like what are your actual like fundamental values, and what do you think like the movement as a whole can like service that's like a benefit to society. And I feel like that's sort of subjective, but in particular, I think that the things that are really exciting have to do with like the last question that I said is like, we're really looking for like experiments that we can actually take like real robust data out of and say, look, we found new ways to organize science with DeSci. We found new access to deploy capital that's more efficient and enables more people to build what they're passionate about than ever before with like NFTs and DeFi. We're using DAOs to organize ourselves in horizontal organizations and empowering people to sort of understand what it is that they care about and do that in ways that they haven't been able to do before because it just wasn't possible. So I think those are like the questions that I would like to see answered. And I think that the way that those get answered is that there really needs to be rigorous science done on some of these things, and there needs to be a lot of experimentation done on all of these things. And I think both of those things are happening.
Well, definitely, if we would, let's say, explore this question deeply, then everybody has their own answer to this. But we were talking about cryptography a lot, and also your position and entropy. And since this interview should be more focused on people who are trying to learn and explore the ecosystem, could you tell us what you do at Entropy, but in more, let's say, explain it like I'm 5 way?
Sure. So the explain it like I'm 5 way would be that I do cryptography at Entropy, and in particular, I work on schemes that are called threshold signatures. And a threshold signature is maybe best compared to a multi-signature, which is where you just have a central party, a central trusted party that says, if I get enough signatures from you, you, and you, then I will spit out my own signature, and my own signature is valid. A threshold signature is where you say, if I get signatures from you, you, and you, we're going to figure out a clever cryptographic scheme to add them together into a single final signature. And that's actually kind of elegant because it allows you to effectively decentralize a model of verification to a group of nodes that hold on to secret shares. And this is kind of like hand wavy, but in a nutshell, what a threshold signature allows you to do is it says, I'm going to split my private key up into parts. And those parts are going to be used to create partial signatures that can then be recombined. And what that actually allows you to do is it allows you to put those secret shares on nodes, on a proof of stake network, for instance, that use that under the securities of stake, those nodes do whatever signing that they need to do, and then those those signatures can get sent off to whatever network as the endpoint. And that's probably going to miss most of the people that are listening to this, but I think the threshold signature stuff and the stuff that we're playing with MPC is actually quite powerful because it allows you to have a bunch of different parties with secret information to do computation simultaneously and produce an output even when the parties don't trust each other.
What has made you to tackle this subject?
So I think like there's a couple of interesting topics in cryptography right now. And all of the topics that are sort of interesting in cryptography tend to sort of ask questions like, what if we have some folks that don't want to trust each other and we wanted to design a protocol such that party A doesn't have to trust B, or might want, for instance, party A wants party B to do some work for them, but they want to trust that party B did the work correctly. And this sort of like all comes back to the fundamental question of, if we have a world of people that want to interact with one another, but one person can abuse another person, how do we create systems such that the maximum possible number of services are available without exposing like risks, either in a game theoretic economic sense or in a sort of like, I'm going to steal your stuff sense. So like the better we get at like sort of playing these games, the more the sort of like available frontier of interesting and worthwhile services we can offer to each other sort of broadens. And I think that's really cool.
Starting off with a couple last questions. How did you actually get into cryptography?
Ooh, okay. So I was a depressed undergrad because I was studying engineering, electrical engineering. And I basically knew that I really liked number theory. And I kind of wandered over to the math department at my school and I took a cryptography class. And I was like, okay, so here's a couple of things that are really standing out to me as rad. I kind of talked about it a little bit in the last question. Like, what are the cool things about cryptography? Well, they allow us to sort of like play these games that open the available network of services to a broader set of services without exposing people to like risk of being defrauded or hacked or whatever. And so like I kind of immediately saw, okay, so who needs cryptography? Well, in the sort of history of cryptography, governments were pretty much the only players in the game of like actual real cryptography. And then that kind of changes in the 70s. And what sort of like, I mean, just basic like encryption, public key cryptography allows is it says there's cryptography that your little brother can't break, and there's cryptography that your government can't break. And I think like it's actually quite interesting because when I was talking about expanding the available set of services, governments have like other ways of like making their services secure than cryptography. Like they have power. And so the people who benefit the most of these services tend to be people with less power, and they actually need the power of mathematical complexity theory to guarantee that their interfaces are secure. Whereas larger, more powerful parties just tend to not need those things as much because they have other ways of enforcing that power. And I thought that was like a kind of like really cool bit about cryptography is like the power is not in like social power. The power is in the mathematics. That's powerful.
Well, following up, let's say on the power to the people, power to the, let's say, not governments and those who actually don't have those, let's say, big corporates. What are the like biggest misconceptions that we have in cryptocurrencies or in the blockchain space?
Well, I think like probably at least half of the things that we're interested in right now will probably not be that interesting in the grand scheme of things. Like when I said that we're playing experiments with cryptocurrencies, experiments with NFTs, experiments with DAOs, experiments with MEV games, and experiments with cryptography. Some of the cryptography may break. The standards of NFTs may just never catch on because it turns out governments are just more robust than I would like them to be. And private property just continues to be captured by entities that refuse to recognize NFTs as such. It could be the case that really DAOs don't enable a much larger Pareto frontier to be unlocked. Like really the misconceptions are kind of like, I think that we're all excited about like the new technology, but it is all an experiment at the end of the day. And I think that there's maybe sometimes a clouding of like the true like level of like, we're really playing games and we don't know what's going to happen. And we should be looking at that like scientists and like reasonable like experimenters, and not as if like we've solved all the world's problems already, which we definitely haven't.
Well, one of my last questions for you is if, for example, somebody would want to get deeper into the security models and ZKs and Schnorrs and all these subjects, what is the like ideal tool or book, podcast that you would recommend to continue their learning?
Yeah, I would totally shill Anna Rose's Zero Knowledge podcast. For people looking to get more into cryptography, in particular zero knowledge cryptography, everyone is welcome to check out the study group that I run through the ZK Hack Discord server. And you can find that through the website zkhack.dev. There should be a link at the bottom. And the things that we're doing kind of look like we're reading through a book called Proofs, Arguments, and Zero Knowledge by Justin Thaler. And Justin and I host that on a weekly basis with a midweek sort of informal. The opportunity to implement algorithms that are sort of like the major keystone algorithms from like zero knowledge tech of the last 10 years is sort of like the focus of the group. So you kind of get a hands-on approach with both the implementation and the theoretical sort of hands-on of like, how does the mathematics and how are the security proofs constructed, and sort of what is the intellectual foundations of some of the interesting ZK circuit stuff that we're using today. So I definitely recommend that anyone check that out. And I've also got a grant for that out on Gitcoin right now. So if anyone wants to check out Gitcoin, you can send me a buck.
All right, following up with our last question, and it is more of a general ecosystem question. When we look at the space, let's say blockchain space or Web3 space in general, how are the, for example, I wouldn't like to say corporates because they are not indeed corporates, but I would say, how are the giants, for example, like Coinbase or those like, let's say, big companies, how are they tackling this like security features and all those issues? Because as we said before, they can have it more, let's say, centralized way and more on their own kind of thing, like, let's say, not open source, like basically closed source, some kind of development and security. How are they looking into basically this topic that we've been talking about right now?
Is the question like, how is like a Coinbase looking into producing new services that are sort of secure?
Exactly.
Yeah. Actually, we kind of have the benefit of Coinbase and company doing some pretty good work in like cryptographic research. I think that a lot of like the implementations in cryptography, in cryptocurrency in general, but cryptography also, benefit a lot by so if you have like several different implementations of a particular protocol, you really would like to look at all of them and like identify the differences in implementation and say, oh, this implementation seems to use abstraction slightly differently. And the availability of different implementations means that you're more likely to find bugs in each implementation and sort of arrive at like the bog standard of like, oh, this is the common implementation that everyone uses and this is actually secure. So I think like companies like Binance and Coinbase are doing a great job of producing like really high quality cryptography libraries that I personally use a library out of Axelar, which is a project in Cosmos, a bridging project. But in general, I think like the work that is done by larger corporates as far as open sourcing their work, when they do so, I think is actually quite a big boon to the community. And by open sourcing, they sort of allow other people to take a look at their work, make their work better, and allow others to learn from their work, which I think is really important. If I was going to kind of criticize them, I don't think there's really that much to be said. You have a philosophical objection to centralization, then of course you're going to say, maybe if there's an option to use a less centralized entity, then yeah, we'll take their open source code and run it ourselves and build our own thing. But they do really feel a pretty massive niche in like the available service frontier to people that maybe don't know where to go. And I think that that's perfectly reasonable that centralized entities can be and should be like your first shop to check out for like new people to the space.
All right, Thor, that was amazing. Thank you for this, let's say, big kind of introduction to all the security system and to entropy in general. And all the links that we have talked about or what was discussed will be put into description. And farewell.
Thanks.